Today, we're going to be chatting about exploring the different Kubecost APIs. So for those of you on the call who have a Kubecost deployment, whether it's the free version, whether it's open cost or an enterprise version, this will be applicable. We'll go through a couple different sections, high level of the different APIs available in the platform. We'll also give some live examples of what the payloads look like, how we can explore some of that data. Like Aaron said, I'll pause later on once I'm in the kind of live demo portion. Please feel free to throw questions in the chat. My other teammates here will be responding, as well as filtering those out and bringing up questions for us to answer in the end. So let's jump right into it and start talking about the Kubecost API. So I'm assuming most on this call are somewhat familiar with the Kubecost platform, may even have it running, may have it running in a business capacity. But Kubecost obviously is a cost management platform deployed on Kubernetes that allows you to break down all your costs, report on Kubernetes and cloud costs, as well as gives you savings recommendations for your Kubernetes clusters that you're running within the federated setup. So out of the box, we have a bunch of different APIs that many people use the front end, and that's totally fine, use the regular UI of Kubecost. But under the hood, the front end is running off of all of these APIs. And when Kubecost was originally built as a project, it pretty much only was the Allocation API. Over time, we've grown to have multiple different API endpoints, and all of them are accessible. They're definitely fun to explore. And sometimes you never know what you're going to find if you dig a little bit into the APIs. Today, we're going to be covering the Allocation API, which was the original Kubecost API. It's really that when you think about Kubecost and allocating cost to a namespace, to a label, that's going to be the Allocation API. We're going to talk about the Assets API and also our new Cloud Costs API. These look more at the individual assets, like the node, the disk, the actual assets themselves versus the logical grouping of spend. And we're also going to look at the Savings API. So the Savings API corresponds with the savings reports in the platform. They give you recommendations for different things like cluster sizing, recommendation right sizing. So we'll explore a little bit of each of these today. I probably will do a part 2 down the line because we do have a lot of different endpoints we can talk about. The Audit and Events API, as you see, you can read about those in the documentation. Those have some different validation of data sources and some other cool things, but we're not going to get into those just yet today. One great thing, and don't be scared by the slide, we don't have to absorb everything here, but the idea behind the Kubecost API is you have common filters and parameters that work across all the different endpoints. So as you become more accustomed to creating API calls with Kubecost, you don't have to reinvent the wheel for every single call. Many of the different APIs support filters like filtering by cluster, node, namespace, label, annotation. Node label is actually a new one that we just brought in. We have some different logic. You can read in the docs a little bit more about this, but all the APIs use this common set of filters, and many of them use the same parameters, like window, where if you want to look at costs like cost for today, for this week, this month, yesterday. I do want to note here that the free version is only going to give the last 14 days of data. So if you have enterprise, you're going to be able to do longer history and be able to do things beyond just the last 2 weeks. Free version, you're going to get these same parameters, but it's just limited in the time, in the data that you're going to be able to get back. So let's talk about a couple of the endpoints that are available to every deployment of Kubecost, whether it's free, enterprise, etc. The first one I want to talk about is the Allocation API. Like I said, this is what Kubecost was originally built on, and we have that base/allocation endpoint. That allocation endpoint is going to allow you to do costs by Kubernetes but also the cloud costs, external cloud costs, and do cost grouping by the things that you care about, like namespace, label, product, owner, etc. You're going to get a full breakdown for Kubernetes by CPU, RAM, GPU, all the different things, which we'll explore in the examples. But you'll get an external field as well. The external field is your out of cluster cloud costs that you've allocated to those specific groups. Let's say you have an S3 bucket and you've tagged it with namespace Kubecost. Well, what's going to happen is if you make an allocation API call for namespace Kubecost, you'll actually see the cost of that S3 in the allocation, but it's going to be a lump sum. It's not going to break it down by different line items. It's just going to be a lump for external. Within the allocation API, you have a couple sub endpoints, and related to what I was just talking about, you have this external allocation endpoint. This gives you the Kubernetes plus cloud, but it also gives you cloud line items. So when we were talking about before, that S3 bucket that is associated with the Kubecost namespace, if I ran it through allocation external, I would be able to see that S3 line item as well as my Kubernetes line items. I wouldn't see it as a bulk blended item. So we'll go into an actual example of this in a few. Lastly, on the allocation API, this is the compute API. So this actually gives you real-time and unique metrics that come in different steps and different granularities. So if I wanted to see the last 7 days broken down by 2-hour windows with 1 minute granularity, that's where you'd turn to the allocation compute API. So it gets you some cool, interesting, very broken down data. If you just want to see the last 7 days, you'd probably just go to the base allocation. If you want to see 7 days with 1 minute granularity, then you'd come here. Although this is a little bit more resource intensive. And at the end of this, I will give a live example of querying all of these APIs. So the next piece is the assets API. Like I said before, this is going to be more of Kubernetes specific stuff. So the number of nodes, the exact nodes, the volumes, which AWS EBS volumes are these tracked back to, the load balancers. It's going to be less about cost per team, more about what did I spend per node, what's the associated network per node, etc. Then we also have the cloud costs API. This is a newer API where you're going to be able to get all the cloud line items for your cloud integration. And for those that aren't currently running it, Kubecost, when you deploy it, you have the ability to integrate your AWS cost and usage report, your Google BigQuery export, or your Azure cost export. And you can integrate those into the Kubecost platform. The Kubecost cost model then processes all of that data, and you have access through the Cloud Cost API to that data. So we can do some cool visualizations and things of not just your Kubernetes costs, but also cloud costs. And lastly on the slides, and I promise we'll jump into a live fun demo in a moment, the savings APIs, which we want to talk about. So these are really important when you're talking about optimization. The first one is the request sizing API. And we're actually on request sizing V2. It's recently got an upgrade with a bunch of new cool things. And these are going to be recommendations for setting container resource requests. So directly asking for the proper settings for a specific container or deployment, and Kubecost gives you back the exact setting that you should use. We also have cluster sizing. These two can be used hand in hand, where potentially you go in and set all your request sizing. And then once you've sized those properly, you can go and look at your cluster sizing. This is going to give recommendations for sizing the clusters by node types and quantities. This isn't actually going to auto scale your nodes for you. It's not really trying to do, what a carpenter would do. But what it's doing is giving you actual instance types, quantities of those instance types, allowing you to dial in that recommendation. So there's some cool info that we can pull out of that through the UI and the API. And then finally, the abandoned workloads. So Kubecost has an ability to identify network costs. And one of the things we get from that is the ability to find abandoned workloads. So those are going to be workloads that fall under a certain threshold of network traffic that we might consider abandoned. So in our weekly FinOps meeting or Cloud Center of Excellence meeting, we could meet, talk about the top 10 abandoned workloads. Are they are they actually things that should be out there? Should they be cleaned up? It's just another data point for you to go and explore. So now I'm going to get out of my slideshow. I'm going to pull up a couple of different tools, open source tools that we can use for some API exploration. We're going to look at how to find Kubecost API info inside the browser. So inside the UI, how do you connect it to the API? We're going to look at a couple of Kubecost API payloads. And then we're going to talk about how you can take that JSON or CSV and put it into a third-party tool like a Grafana or a Quicksight. So let me just make sure that I'm sharing my whole desktop here or Google Chrome. Right back out. So Aaron, give me a thumbs up if you can see my screen here. I think we should be good.
Yeah, you're good, Andrew.
Awesome. So what we're looking at here is Node-RED. Let me just clear some of this up so it's not so noisy. Node-RED's an open source tool. It's kind of like a Postman. It allows you to set up API calls and just explore the payload. So I'm just using it to send an HTTP request to our different endpoints. In this, I have set up, first of all, I've set up the URLs. In this case, we're just pointing it to demo.kubecost. So this would be either the external URL of your Kubecost or the internal, whatever URL you have exposed. And each one of these little setups is going to make a call to the API, and we're going to look at the payload. So the first one here, we're actually looking at the model allocation, that base allocation. I had it set to window 30 days, but I'm going to just set it to 7 days because the free version would have up to 14. So we're going to aggregate by namespace, and we're going to have external cost be true, accumulate equals true. There's a bunch of these parameters. They're in the documentation. I can send that as a link when we send this recording out. That it's exactly what I was showing before with window, aggregate, all these different fields that can be used with the API. So I'm going to deploy. I'm going to pull the trigger on this. Whoops. Sorry. That's why we're doing it live here. So let me just do this. Done. So I just made an API call. It's requesting. Now I get the API back. So I get my 200 code, and then I get the data level. This data is sending back one lump sum because I set it to accumulate of all the different namespaces over the last 7 days. So this is showing me my one array here. I have all my different namespaces because if we look back at the call, I'm aggregating by namespace. And I'm also accumulating true. If I change this to false and I deploy, now it's going to give me 7 objects because it's going to give me 1 per day. So you have the ability to customize this as you need it, whether you want to do it over each daily time period, sum it up into one lump sum. And now if I go to each day, my 7 days of the last week, 0 through 6, I can see all the namespaces. It also has idle costs. You can choose to share that as well. But if I go into Acme Fitness, I get all this cool information about what happened with the Acme Fitness namespace on this day, which is February 23rd. It gives me the time window. It gives me the properties, all the different minutes it ran, CPU cores, pretty much all the information you'd want to get. The UI of Kubecost sums some of this stuff up for you, but you have access to all this. As I go down, you'll see there's a lot of different things here. And we have the ability in the Allocation API to shape this however we want. So that's an example of the Allocation API. You can do it for more than just namespace. So if you had specific label, if I want to say like label app, you could do that. If you want to create a label group, which is a concept within Kubecost, you can create a label group. So in my case, if I want to aggregate by product, I can change that. Product is a group that I've defined within my Kubecost API, and I can hit that. And now I can sort and get all my costs for the last 7 days by product. In this case, my products are Acme Fit, Cert Manager, etc. So you could do this by environment, team, anything that you want to see and slice and dice by. These will have not only the Kubernetes costs, it will have the external cost if there is any. But you'll notice how it's just one lump sum. And in this case, I have 0. So I'm going to show you an example. I'm going to clear my palette and I'm going to go to the allocation external. So this is the next layer down where we want to see external stuff as well as seeing the Kubernetes stuff. So I'm not going to get too crazy into going into every single parameter here, but what it is we're looking at, in this case, aggregating by label app, and I get my totals. So my total cost for everything that falls under the filter that I just did. Then I also get my items. And then these are all my things that fall under label app. You'll see my undefined. So all the different cloud services here that do not have an app label, like this Athena cost. But if I go down to 3 or 4, I have my cost analyzer app. It has Kubernetes costs, CPU costs, RAM costs, but it also has $17 worth of external costs. And in the API, I can go and look and see that it was $8 of S3. It was $8 of Cloud SQL. So this is all here for you. And this is how you can associate external costs with Kubernetes costs. Now I'll take a quick pause and just flip to the Kubecost UI itself and show how these are linked. So when I'm looking at my allocations report within the Kubecost UI, I'm basically hitting the allocation API. And you can come in here and do things by products, do things by labels, most of the things that you're doing in the API. If I view the inspector on this page and I go to network and I refresh, we'll see that it actually does hit this allocation API in the backend. And if you look here, this is very similar to what I'm doing in Node-RED. I can click on it, I can copy it, put it right into the browser, and it's gonna, whoops, of course I did the request URL, need to get rid of that part. And then it gives me back that JSON. So I have this publicly exposed, that's why I can do that. But you'll see all the UI is feeding off that backend API. If you go into advanced reporting within Kubecost, this has the external column, and the external column is the same thing as that allocations external. So when I view by product and I look at cost analyzer, I see that Amazon S3, that $8, that's directly pulling from the allocation external API, which I was looking at here. Cloud, Amazon, S3, $8. So that's how the UI is linking back to this API. I'm going to keep it moving here because we have a couple other things to talk about, and then we can pause for questions and go, as deep as any of the attendees want to go. The allocation compute, this is what I was talking about with the different step windows. So in this one, I'm looking at the compute, but I'm looking at a 1-day window with a 60-minute step and a resolution of 1 minute. So it's going to give me 60-minute chunks over the 24-hour period, and it's going to give me 1 minute resolution between. So if I do this, this might yellow me. I was having a little trouble with this earlier, but the idea is you can get much more granular data, although it is a little bit more resource intensive. Not everyone may need this level of granularity. And you can see it's so much, it's giving me 1 minute payloads for 60-minute blocks. So it does take a little bit. We'll let that bake for a second while we look into assets. So while that's running, we also have the assets API. So the assets API is going to be direct Kubernetes assets. So when I query this, we're looking at assets, we're aggregating by type. And this payload, I'll pull it out just so you can see. The data array is the last 7 days. And I have it by type. You'll notice that this is the Kubernetes assets. This is going to be cluster management fees and how much those cost, disk fees, load balancer. You can get a ton of information, as an AWS load balancer, the window. So there's a lot of information you can come in here and mess with. Many of these things are also shown in the assets API, the assets UI. So if I come in here on the flip side, I can see node, cluster management, load balancer, disk, but just showing how everything is available in a format that you want it in, whether it's this business UI, whether it's a JSON. You also can export CSV or PDF or CSV through the API. We'll get into that Grafana there in a moment. So that's the assets. I'm going to clear this again. The cloud costs is a new one. So this is hooking into your AWS, your Google, your Azure cloud exports. And what this gives you is a set of information, same kind of thing, last 7 days, but it's giving you all your cloud services. So you can see here, these are non-Kubernetes services like CloudTrail, Glue, Lambda, CloudWatch. I should have some Azure in here as well. Maybe not, maybe I only have Amazon in this particular, but this is multi-cloud. So we'll pick up all the different cloud providers. You can come in and what's kind of cool, I can see, okay, of EC2, actually in my Amazon account, my EC2, 73% of my EC2 is used for Kubernetes. So that's kind of like a quick fact you can pull out there. And then also the net costs. A soon to be update, we'll be able to get the line items that make these up as well. So you'll be able to really get awesome drill downs and things of that nature. But we just rebuilt this API. It's much more performant than our old API. It takes much less memory. So we're going to be able to do a lot of cool things with this Cloud Cost API. Also has the window, so a bunch of cool things there. And then lastly, we'll get into the savings and we'll get into some questions. So savings is going to be less about cost reporting, more about actionable items. And we have right sizing for resources, right sizing for clusters, and then that abandoned workloads that I mentioned before. So let's take a look at the right sizing for resources. I'm now looking at my savings request sizing v2. I'm using an algorithm CPU of max. I'm using a RAM CPU algorithm RAM of max. I'm using a target CPU utilization of 80%. So it's going to try to give 20% more resources on top of that. RAM utilization 80%, window 2 days. So that looks good to me. I'm going to send it to my API. Now this is going to give me back the total monthly savings for everything in my filter. It's going to give me 42 recommendations, and I can come down and look at those specific recommendations. It gives me the cluster ID, the namespace, the controller, its current last known requests, its recommended, the savings. So a lot of information in here for you to go into of all the different recommendations. And you can filter this down to just a specific container or deployment or namespace. So I'm just doing a broad one with this call. I'm saying, give me everything over the last 2 days. You can specify this down. Where this is cool is if you do a CI/CD type automation where you can hit the Kubecost API, get the recommendation request back, patch it in. We do some automation with this, but the API is here for you to kind of work it into your own tools. So that's the right sizing for resources, right sizing for clusters. I'm going to click that. We'll get back right sizing for clusters. So these are my 2 clusters. If I look back in the UI and I go to my overview, you'll see that it matches here, a Dawson debug, test, delete me, and my rate card tester. And if I go back, those are my 2 clusters that I'm getting recommendations for. And we have recommendations. We have kind of simple recommendations, multi-recommendations, bunch of different recommendations for you. We break down why we're making the recommendations, different pools. You can come down, you can see the parameters. So this is handy because we're using these parameters to decide the recommendations. So the total amount of static vCPUs on my cluster is 0.385. My total static RAM GB is 1.9. So just handy stuff for you to know. Current cluster info. So really a ton of different stuff that you can bring in here and use. We're, obviously talking to our, our friends at AWS of how we can work side by side with Carpenter and help, make those 2 tools work, well together using our recommendations, using Carpenter's actual scaling. But all this information is here for you. The last one I'm going to go into before we pause is going to be the abandoned workloads. This is going to use our network deployment to actually figure out the bandwidth of different containers. So I'm looking at abandoned workloads. I'm looking at the last 2 days, and I'm looking at a threshold of 500. So that's actually 500 bytes. So we're looking at really small amounts of traffic going to our different containers. And I'm going to click this button. And here are all my abandoned workloads. So these are pods that we think that, well, we don't think, we know that they violated our rule. This had 0 ingress and egress, but it's actually this one's not too bad. But you can find sometimes requests that are taking up like vCPUs and they're not doing anything. So it's just another FinOps practice. You could automate this, you could clean this up automatically, but it just illustrates how we can go through the different APIs. Now, I did want to take one more, I said I was going to pause, but I wanted to show one more thing here. All this same information that I'm getting can be pulled into visualization tools like Grafana, like Quicksight, like Looker. And you can do that usually through either a JSON or CSV endpoint. So I'm going to take Grafana as my first example. I've gone in and I've created, and we actually have a GitHub repo for this to show you how to set it up, using Grafana's default JSON data source. All I'm doing is pointing at those APIs, the same ones that we were just looking at in the HTTP requests. And I'm using JSONPath language to query that. There's no database involved here aside from Kubecost model API. So whenever I view this report, it's going out, it's fetching that JSON, and I'm able to pull in that information. So if I look at this particular report, I have my owner groups by spend type last 30 days. So this would be an enterprise where we have 30-day history, but I can see I have a bunch of undefined external costs, which have no owner. I see my colleague Lynn has some $568 of external costs. He may be on the call now as well. We also have our sales demo. So this is $530 of external costs. If I go into this, it's just using similar type of JSON path exploration where we're kind of dropping down those payloads and getting the information. And we're setting a couple parameters like window, 30 days, aggregate by owner, those same parameters that I was talking about before. And what this allows us to do is visualize it. So for example, my sales demo, I have this here, 530. I can come down here and see, all right, of that sales demo, external costs, what was that made up of? It was made up of EC2 and EKS. Well, I know that if I see EKS, that means it's a Kubecost cluster that hasn't been installed yet with Kubecost. So I can go into my other API data and find it. I could go into my UI. And here's some other examples of Grafana where we just had some different chart types. This is all in a GitHub repo we can share. And these sample dashboards actually are there too. You can load them in. And then I also wanted to show Quicksight. So AWS Quicksight, we are, Lynn actually on our team has written an Athena cron job that you can set up that dumps the allocation information into a CSV file that you can feed as a data source into Quicksight. So this is just like month-to-date cost by product using that same API data. Again, here, pulling out the columns. So it's very flexible. Most of our customers, are happy with the UI. And then we have our solid 30% that love to pull the JSON and the CSV into their own dashboards and Power BI, Looker, Grafana, all that fun stuff. So I'm going to pause. We can answer some questions. I'm hoping that this kind of little light bulb for some of you out there today on what's possible with the API. We're happy to answer any technical questions now or in a different session. And I most likely will have a part 2 of this, exploring some of the additional ones. We have some that I didn't even talk about, like our network APIs and network cost APIs. So from there, I'm going to take a pause. I'm going to stop my screen share and we can take some questions and I can jump back into the screen share if needed.
Hey, Andrew, that was awesome. Question I typically get is, especially when you were using Grafana, why not just use the Prometheus data from Kubecost?
Yeah, great question. So I didn't actually specify this, but this Grafana here is just sitting in Google Cloud. It's totally external. It's just hitting a public API. And we do have a Grafana that comes bundled with every Kubecost. And what it does is exactly what Jesse just said. It looks at the local Prometheus as its data source. And this is great. we can do this because it gets the real-time raw metrics. But the reason why you'd want to use the cost model, which is shown here, is because the cost model contains the reconciled data from the AWS cost and usage report, the Azure cost export, the Google BigQuery. So the Prometheus is going to show good stuff like the RAM usage and requested, more like live data that we want to get by looking at the cluster itself. The cost model, which you can also access through the local Prometheus on the Kubecost deployment, and we're working on making that a built-in data source on the Helm chart. But the cost model has that reconciled data. So when I say reconciled data, I'm going to look back at my UI because it's easy to visualize it here. By default, we give every container a cost based on an hourly rate, a retail on-demand rate. But when you integrate your cost and usage report or Azure export or BigQuery, we actually adjust that cost based on your real spending. And when you use the cost model API, which if I jump back to allocation or allocation external, this is taking that into account. It's taking the actual costs of the adjustments. And actually, I'm going to go into this one because I think we have payloads that say adjusted in them. It's actually taking the adjustments and applying them. So if I come to any of these, you see CPU cost adjustment. So unfortunately, this one has 0. But if you actually had adjustments from your bill, they would be reflected in here. So it gives you your accurate costs is really the short answer. We're also adding more special sauce Kubecost type stuff in the cost model that you can pull out, like the network cross-zone costs and all that fun stuff. So it is unique, but hopefully that answers that question. Was that able to answer the question, Jesse?
Yeah, that's perfect. Thank you. How about just in general, I mean, while you're on the topic of reconciliation, just what kind of guidance you have for how long it takes the cloud provider to have accurate billing?
Yeah, so we definitely recommend, looking at it from a 24 to 48 hour window with the cost adjustments. When you're in the last 48 hour zone, even sometimes 72 hours, depending on how large of an organization you are, that's a good zone to get in and look at the real time. You may come in here and look at last 24 hours and see that some of this looks a little inflated cost-wise. A lot of times that's because the savings plan or reserved instances haven't been applied yet, but you'll still have the same resource usage per container. So that's not going to change based on your rate. You can still come in here and understand what's being used for resources in the last 24 or 48 hours. Then what happens is once we get the cloud costs, as you can see, my last cloud costs here from the 28th, we then apply those on top. So we're working on better, integrating both of these reports so you can just see, as soon as the last 7 days hits and we get unreconciled, it's designated. But you have both those abilities, looking at the last 24 to 48 in real time, and then looking at the reconciliation in the cloud costs as we collect those costs, as you can see here, like EC2, S3, and you would see Google and Azure and other in here as well. Cool.
We have a question now. Could you please post a link to the repo?
Yeah, absolutely. I can do that. That is a public repo, and I'll just jump into GitHub because everything is public here. So if you go to our cost analyzer Helm chart and you go to Kubecost, you won't be able to see a lot of the stuff in there that I can see, but you will see a lot of public charts. And let me just actually pull that up, which is going to be Grafana. It's Grafana Kubecost integration, Kubecost Grafana JSON integration. So this was just written in the last actually 5 days ago, so it's brand new. It goes through how to set up the JSON data source, kind of links back to some of the API docs that I was talking about in today's session. Also talks about the cost model and why you would want to access through the cost model. And then there's some examples. This is actually that dashboard that I showed. So you can import this into Grafana and it'll have the different setups that you can kind of look at. Then I also wrote an article on using the JSONPath queries with the Kubecost API, because that is one funky thing with the Grafana. You have to use JSONPath, and you kind of have to be at the same level with your reports. So if you notice here, everything is data, items, blah. It kind of yells at you if you don't put it all on the same level. So this just goes through a couple different payloads and the way to access it. It's actually very relevant to this convo that we're having here. So we'll send that. I'll actually send it in the chat, and we'll send it out with the materials as well.
Sweet. Thank you, Andrew. That is it for questions from the audience.
All right, great. So the last thing I'll leave everyone with, we can give everyone a little bit of time back. The docs.kubecost.com is your friend, whether you're on enterprise or business or free or even open cost somewhat. We have our open cost docs as well, but the API directory has really been gone through a ton in the last few weeks. We've been going through and just trying to make it better, trying to add all the different schemas, different parameters. So we're making a large effort to make this easy to read, give you the right stuff that you care about. If you have any feedback on this, let us know. Should see a lot of different stuff in here for all the stuff I mentioned, like the assets API, abandoned workloads, some of the other APIs that I mentioned, I can touch on in probably part 2, like the allocation trends, the asset diff API. And then just in general, we've been redoing our docs. So it should be more searchable. It should be a lot more advanced configuration type articles in here. And always feel free to reach out to us as well on Slack. We have our Slack community that anyone can join, or reach out to us directly through the contact, and we're happy to help.